Okay, well, hopefully that doesn't happen again, but now I'm recording again. So are we okay with how I got my u and my dv?
Yes.
Okay, so then from here, what's going to happen is I'm going to use my uv minus the integral of v du. So I'm going to get e to the x sine of x minus the integral of e to the x cosine of x dx. Agreed? But what do we notice here?
Still a product.
Still a product. So we have to do our u and our dv again. And so in this case, it's going to be cosine of x, and my dv is going to be e to the x dx. So my du now is going to be negative sine of x. My v is going to be e to the x. And so what I'm going to have is e to the x sine of x minus, put the brackets, e to the x cosine of x minus the integral of e to the x sine of x dx. Right, I didn't put the dx there, bad habit. That becomes a plus, right, because of the negative sign. Do you guys agree?
Agree.
Okay, now, something crazy. I'm going to write the original problem. So the original problem is e to the x sine of x dx is equal to this thing that we've got. Do you guys notice anything?
The original equations and the solution.
Awesome. The original problem that we have is part of the solution. So we have to pay attention to this and notice this. If we don't, we end up in an endless loop. You're going to end up having more and more and more and more things happen, and you're never going to find an answer. So it's imperative that you guys remember what your original problem is, because we might have things that end up looping. Okay? So what I'm going to do is I need to bring this to the other side. So when I do that, I'm going to get 2 integral e to the x sine of x dx is equal to e to the x sine of x minus e to the x cosine of x, correct? And then I have to divide by 2. So I'm going to get the integral of e to the x sine of x dx is equal to 1/2 e to the x sine of x minus 1/2 e to the x cosine of x plus some constant c. And that is my solution. This is called a looper, where the original problem ends up as part of the solution. And so the way to remedy that is we need to be aware that it's there and move it to the other side, remembering that we're balancing the equation. We okay with that?
Yeah.
Okay, nothing is worse than not seeing the loop and doing 2 and 3 and 4 more steps of your integration by parts and being like, I'm ending up nowhere. So be aware when you're doing these problems that this is a potential loophole, okay? All right. I'll give you another second to copy this down, and then I'll do the next problem. I'm finally going to do one that's a definite integral. Let me know when you're ready.
All right, I'm ready.
Okay. Is everyone else all right?
Yep.
Okay. All right. So then from here, going to the next problem, we have the integral from 0 to 1 of tan inverse of x dx, right? And so to do this problem, the only way we can do the integration of inverse trig is to do integration by parts. So again, remembering this, my u should be what?
Inverse tan of x.
That's right. So we're going to have inverse tan of x. So then dx is my dv. Now, what is the derivative of inverse tan? You guys totally remember this, don't you? Like Aaron said earlier, crickets.
Is it 1 over 1 plus x squared?
That's it. 1 plus 1 over 1 plus x squared is the derivative, and then v is going to be x. So then when I do the problem, uv minus the integral of v du, I'm going to get x tan inverse of x minus the integral of x over 1 plus x squared dx. Agreed?
Agreed.
Okay. Now, I'm not going to do the definite piece to the very end, so don't worry about that. What do you guys know about this? It's not a product. It's a quotient. I mean, I could write it as a product, but that won't help. What can I do?
Can you take two separate integrals and then subtract them?
Unfortunately, if the problem was written the other way, where it was 1 plus x squared over x, I could have done that. But since the numerator only has one term, I cannot do that. Just trying to see if you guys remember your old Calc 1 stuff. Some of you guys were my students. Come on. All right, I'll help you. It's a u substitution. So my u in this case is going to be the denominator. Oops. So u is going to be 1 plus x squared. So du is going to be 2x dx. But I don't want 2x dx. I just want x dx. So I'm going to go 1/2 du is x dx. Is this starting to get some cobwebs out?
Yes.
So I'm going to get x tan inverse of x minus my new integral is going to be 1/2 1 over u du. So I'll get x tan inverse of x minus 1/2, and the integral of 1 over u is? What do you guys think?
Absolute value of u?
It's ln of u, right? It's ln of u in absolute value. But we know that that was a substitution, so we're going to rewrite it as negative 1/2 ln of absolute value of 1 plus x squared, right?
Right.
And now we need to evaluate this from 0 to 1. So we're evaluating the whole thing from 0 to 1. So what I'm going to end up getting is 1 times tan inverse of 1 minus 1/2 ln of 1 plus 1 minus 0 times tan inverse of 0 minus 1/2 ln of 1. What do we know about the minus side? What do we know about this? What's 0 times tan of 0? Tan inverse of 0. What is that?
0.
0. What's 1/2 ln of 1? Okay, I'll help you. Ln of 1 is 0. Okay, so that means this whole piece here is going to be 0. So I'm going to end up with tan inverse of 1 minus 1/2 ln of 2. No longer need the absolute value because I know it's a positive. Tan inverse of 1 in radians is pi over 4. So I'm going to get pi over 4 minus ln of 2, and that is my solution. Did you guys realize you're going to be learning trig, algebra, calc 1, regular algebra, all in the class? It all comes back. Are there any questions on the process for this problem that I just did?
You just leave it up there for a bit?
Yeah, no problem, of course. Of course.
Would the answer still be accepted if it wasn't converted to radian?
So we're talking about inverse, right? You could have called it 45 degrees, but 45 degrees isn't a number. So typically when we're dealing with inverse functions, we go to radians.
Okay.
Okay. It's a little bit to absorb, right?
Yeah.
Yeah.
For sure.
So all chapter 7 is techniques of integration, and so it can become daunting. But it's also quite good because it's going to reinforce so much of the math that we already learned in the previous course. And those of you who had me, I stressed knowing those integrals, right, and those derivatives. And this is why you need to know your integrals and derivatives, because in chapter 7, they're going to get interchanged back and forth. Let me know when you're ready.
All right, I'm ready.
Okay. All right, so what I'm going to do, this is where I'm going to stop with 7.1. I'll just record the stuff that I'm going to do for the practice for the exam. Yeah, I'll just record it, whatever. So here are some problems that you should be able to do relatively easily. So all of these problems should be problems that I'm going to put up, and then you guys should be able to do, and then we can discuss them. Okay? So this is for, this is a review for the exam. Sorry, people were trying to bug me. So here we go. I gotta mute these people. Sorry about that, guys. Okay. Find the length of the sides of the triangle PQR. And then I'm going to give you P is 6, -1, 1. Q is 8, 0, 3. And R is 9, -2, 1. All right? So if we want to find the lengths to the sides of the triangle, how can we do that?
Get the vectors and then the magnitude of the vectors.
Yeah. So we're going to have to find the vectors and then find the magnitude of the vectors. So how many vectors should we end up having in this case?
3.
There should be 3. So you should have a vector P to Q, right?
Yes.
A vector from Q to R, and a vector from R to P, or P to R, however you want to call it. It doesn't matter to me. And does that make sense how I selected the vectors that I'm choosing? Because that's important for you guys to understand. Do you guys all understand that or no?
Yeah.
Okay, so you're good? Okay, so the vectors then, to find the vectors for each of these, what would we get? Isn't the vector 8 minus 6, 0, minus 1, 3 minus 1?
Yeah.
So that should be 2, -1, 2. Right?
Yes.
And then the magnitude of that vector is going to be...
Professor?
Yes.
Should that be a 0 plus 1?
Yeah, it should be 0 plus 1, right, Professor?
Oh, yes, correct. My bad.
-1, yeah.
My bad. Okay, so then to get the magnitude, isn't it the... it's 2 squared plus 1 squared, or no, minus 1, right?
No, it's positive 1, right? Because it was 0 minus negative 1.
Yes. Well, you're right. But the thing, it doesn't matter because it's squared. But yes, you're right.
Yeah.
It should be 1 squared plus 2 squared, and so that's going to give me 9, right? Square root of 9. So the first one is a length of 3, right?
Yes.
Okay.
Yes.
I'm just going to show the first one. You guys can find the others to confirm, but QR should be 3 in terms of not the vector, but the magnitude of QR should be 3, and the magnitude of RP should be radical 10. And then I'm going to ask a question like, is this a right triangle?
No.
How do we know it's not a right triangle?
The sides are the same.
By the Pythagorean theorem, right? A squared plus B squared has to equal C squared for it to be a right triangle. Right? If it isn't, then that doesn't work, and we're going to get 18 is equal to 10. That's not true, so it's not a right triangle. So what type of triangle is it?
Isosceles.
It's an isosceles. And the reason it's isosceles is because 2 of the sides have the same length. Okay? You good with that? There's going to be at least one question like this on the exam. Seems reasonable, right?
Yes.
Yeah.
Okay, the next one is, I'll give you something like find vector A plus vector B, or find vector A plus B, 7A plus 9B, find the magnitude of A, and find the magnitude of A minus B. We did this in the homework, right? If I give you that A is a vector -3, 4, and B is a vector 9, 1, we should be able to find this relatively easily, correct?
Yeah.
All right, so I'll do the sum one for you guys. So A plus B would simply be -3 plus 9, and 4 plus 1, which should give me a vector of 6, 5, correct?
Mm-hmm.
To find the magnitude of A, that's simply going to be -3 squared plus 4 squared, which will be 9 plus 16, which should give me 5. Right?
Right.
Okay. I'll leave this one for you guys to do. Tell me if you can see that the answer is 13. I want you to try it right now. I want to see if you guys can actually get the 13 so we can confirm it. Were you guys able to show it? One thing that I will promise you guys about the exams is every problem that we do for the exams will be something that's been in the homework or I've covered in class on the notes, okay? I'm not going to try to surprise you with something. I don't think that's fair.
I'm getting 3 root 17.
Okay, so let's see. So first we have to find the vector a minus b, right? So that's negative 3 minus 9, and then 4 minus 1. So that should give me a negative 12 and 3. And then the magnitude of that should be a negative 12 squared plus 3 squared, which is 144 plus 9, right?
Correct.
And then that's going to be 153. Oh yeah, that's not 13. Oh, I see where my mistake is. Silly me. From the example that I was giving, it was 13. This is the correct answer for the problem we gave. I didn't write down the sign on the example that I had in my notes. That should have been a negative 1. If you had negative 1, that would have been a 5. Then that would be 25. That gets me to 169. Does that make sense? So that's why
Yes.
that's why this isn't 13, because I left out the negative. So the problem that we just did with 1 being positive is square root of 153. But you guys get the process, right?
Yeah.
Okay, that's what matters. Okay, let's do another problem. And don't worry, I'll post these notes right after class right now. Okay, find the unit vector. So now I'm asking you to find the unit vector of negative 7i plus 4j minus k. So we have to find the unit vector for this. Can you guys do it?
Yeah.
All right, go ahead and try it, and I'll do it for you in a second. Let me know when you're ready, and I'll work that out.
I'm ready.
Okay, so the first thing that we need to do is we need to find the magnitude, correct? And so the magnitude is going to be negative 7 squared plus 4 squared plus a negative 1 squared, which will be 49 plus 16 plus 1, which is going to look like it's 66, correct?
Yes.
And the reason I do that is because I remember that the unit vector is A over magnitude of A, correct? And so my unit vector for this is going to be negative 7 over root of 66 I plus, should be 4 over root of 66j minus 1 over root of 66k. Agreed?
Yes.
All right, pretty straightforward, right? Okay.
I have a quick question.
Yep.
So on a test, if we start with IJK, do you want us to finish with IJK instead of brackets?
For me, it'll be interchangeable, but my exam will be on WebAssign. So since it's going to be on WebAssign, you're going to have to look at what.
Yeah, they require the IJK.
Yeah, they might require the IJK, and that's part of the reason also that I want you guys to submit your work to me, because let's say that you did do it as a vector and you got it wrong, I can go and change that by looking at your work. Does that make sense?
Yes.
Okay, so here's the next one. I'll try to write it so you guys can still see number 3 just in case you need it. I want you to find the angle between the vectors. And here are the two vectors. A is 1, -4, 1. B is 0, 7, -7. What I'm going to ask for is 2 types, the exact and the approximation. Okay, I'll be right back, okay? I'll be back in just a second. Keep working on the problem. Sorry about that. All right, are you guys ready? Not yet?
Yes.
Okay. So in order to be able to find the angle in between, we need to remember cosine of theta is equal to the dot product over the product of the magnitudes, right? Or the magnitude, yeah, the product of the magnitudes. Got to say that correctly. So the dot product for this is what? What did you guys get?
It's a -35.
That's right. It should be -35. The magnitude of A,
18.
the magnitude of A is 3 rad 2 or 18, right? And what about the magnitude of B?
98.
Root 98, which is the same as 7 radical 2. Correct? So then when we do that for the exact, I'm going to go cosine theta is going to be -35 over 3 rad 2 times 7 rad 2 is going to be 21 times 2. 21 times 2 is 42, right? So then theta is going to be cosine inverse of What goes into those two together? 7 goes into both, so I'm going to get 5 over 6. And so the exact answer should be this. Okay? The approximation you're going to do in your calculator, and you should get an approximation of 146 degrees. Are we okay with that?
Would the 5 over 6 be negative? Or
Oh, yes. It should be negative. Thank you. Yeah, there should be a negative there. In fact, clean that up. All right, are we okay with that?
yes.
Okay, next question. I want the direction cosines, and I want I want the direction cosines for this thing. So the vector that I'm giving you is I minus 3j minus 7k. So I want to find out what cosine alpha is. What is cosine beta? What is cosine gamma? Okay, and then once you find those, I want you to tell me what alpha, beta, and gamma are. I did these in class. Do you guys remember?
Yeah.
Yeah. So far everything's been pretty straightforward, right?
Yes.
All right, let me know when you're ready.
I'm ready.
Yeah, I'm ready to.
Okay. Let me show you this one so you guys can figure it out. So the first thing that we need in this problem is we need the magnitude, correct? So the magnitude should be 1 squared plus negative 3 squared plus negative 7 squared rooted, and that's going to be 1 plus 9 plus 49, which gives us the root of 59, correct?
Correct.
Okay. Now what's going to happen here is cosine alpha. We need to remember that cosine alpha, cosine of any of them, is simply going to be, cosine alpha is going to be your a over the magnitude of a. Cosine beta is going to be a1. This one will be a2 over magnitude of a, and then cosine of a gamma is going to be a sub 3 over magnitude of a. Did someone have a question? Or are we okay?
We're good.
Okay, so then this first one should be 1 over root of 59. The second one should be negative 3 over root of 59. And then the third should be negative 7 over the square root of 59. And then with your calculators, you can go find alpha, beta, and gamma. And just so you guys know, the approximations for alpha, beta, and gamma are 83 degrees, 113 degrees, and 156 degrees. And this you could find with your calculator, correct?
Yes.
Okay,
Yes.
very good. Any surprises so far?
No.
All right. Let's look at this one. And from here, if I give you the point 2, 0, 2, Q is negative 2, comma 1, comma 3, and R is, 5, comma 2, comma 4. If I want something to find me a non-zero, so for A, find a non-zero orthogonal vector to this, what would that be?
The cross product of two vectors.
That's correct. It's a cross product of two vectors, so you're going to have to use two of these vectors, right? So you'd have to create them. So I'd do like PQ cross with PR. So there's actually, in this problem, there's actually more than one answer. So it just depends on what you end up getting, right? Depending on what point you're using as the perpendicular. Does that make sense?
Yes.
Okay. So one of them is 11j minus 11k. Now, for part B, I want you to find the area of the triangle. And we know that the magnitude of the cross is the area of the parallelogram, right?
Yes.
And so the triangle that would be created would just be half the area of the parallelogram. So 1/2 the magnitude of the cross product, PR, not QR, is going to be 11 radical 2. And you guys can find those, correct?
Yep.
Yeah, I'm just trying to leave you the solutions so you guys can verify them. But and if you have any questions in terms of me showing how to do these, I can definitely show them for you. But these are all things that we've definitely hit on in the notes and on the homework, correct?
Yeah.
Okay. All right, now let's try some other problems. You guys ready? Here's number 7. Number 7 is I'm going to give you a force that is 8 pounds. That's 8 pounds. A force of 8 pounds is required to hold a spring stretched 8 inches. Okay? Beyond its natural length. I want to know how much work is done in stretching it from its natural length to 11 inches. Beyond its natural length. Are you guys okay with this problem?
Yeah.
All right.
I got 16.
Okay. 16.
I got 5.
Okay, so let's see what happens here. So let's walk through it. So we know since we're talking about spring constants, we need to use this equation, correct?
Yes.
And if we're talking about force, force is what kind of units?
Foot pound.
It's foot pound. So if we're talking about foot pound, how much is 8 inches in terms of a foot?
2/3.
It's 2/3. So the stretch here would be 2/3 times k would be equal to the force that's needed, and the force that's needed in this problem is 8, correct?
Yes.
So then our k is going to be 24 divided by 2, which is 12. Do you guys agree?
Yes.
Okay. So then from here, to go from, and that force that was needed was, the force was from natural to 8 inches, right? Now we want to find natural to 11 inches. Right? So what should we do?
Right, 11 inches as feet, so it'd be 11/12.
Okay, so the integral should go from where to where?
11/12 over 0.
0 to 11/12, correct?
Yes.
Of 12x dx. So that should give us x squared, 6x squared, evaluated from 0 to 11/12. Are we in agreement?
Yes.
So that gives us 6, 121 over 144. Does 6 go into that? I need a calculator. Oh, it should. 144 divided by, 6 is going to give us 24. So 121 over 24. 3 goes into, let me see what is 121 divided by 24. It's going to be 5 and change, right?
Yes.
5.04, blah, 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 blah. And that's the force that's needed. We okay?
Yes.
Okay. Not too bad, right?
Oh, what would be the units?
Oh, okay, so it's a force. Since it's a force, what's a force going to be? Or I'm sorry, work. What's work?
It's would it be foot pounds?
Well, that's right. In this case, it's foot pounds because we're talking about foot pounds. It would have been newtons, joules, I'm sorry, if we would have been talking metric. Does that make sense?
Yes.
So that's one of the things you want to remember. What you're working on. Are you metric or are you in standard? If you're in metric, it's joules. If you're in standard, it's foot pounds.
Okay.
All right, cool. All right. Let's do another one. All right, so I have a cable. Who would have thought that I was going to put a cable problem in here, right? That weighs 8 pounds per foot, is used to lift 750 pounds of coal up a mine shaft 500 feet deep. Find the work done. So the first thing that I want you guys to be able to do for me is write this in this form. So we know the definition. What would this part be?
Would be 8x and the I.
So it would be 8x sub I, but there's another piece. There's a constant. And here's how you can think of it, right? We have the cable, which is changing, right? Because that's a depth. But what's at the bottom of it? Isn't there something that weighs 750 pounds?
Minus x.
So it's not minus, it's going to be plus. Because this is 750, and then every foot that you pull this up is 8x, right? It's going to be doing it. So this should be 8xi plus 750. Does that make sense?
Yes.
Okay, now the actual integral, we want to evaluate the integral. We have to be able to translate that into integration, right? So into integration, the integral is going to go from 0 to what?
500?
500, that's right. Because that's the distance we're pulling, right? It's going to be 8x plus 750 dx. Now, let's evaluate this thing. So we're going to get 4x squared plus 750x evaluated from 0 to 500. So we're going to get 4 times 500 squared plus 750 times 500 minus 0. And I'm good, but I'm not that good. 500 squared times 4 looks like 1,000,000 plus 750 times 500 is 375,000. And we did this in standard form, so this work that's being done here is what? What unit? Foot-pounds. We okay?
Yes.
All right. This is a pretty good example of the problems that I'm going to give you. The exam will have 10 questions on it. And like I said, I'm going to give you 2 opportunities for each problem. So if you get it wrong, there's another opportunity. I'm going to allow you to have a sheet of notes where you can put formulas. I do not want example work out there. Okay?
Okay.
When you do the PDF for me, please send me the PDF with your 1 sheet of notes. Okay?
Okay.
All right.
So send that at the end of the test, right? So when we submit the test,
Correct.
put the PDF.
Correct.
Oh, okay.
After you've submitted the test, WebAssign will have a grade for you. You'll submit your work to me so I can look at your work, so I can give you partial credit, or even give you full credit if for some reason your answer didn't mesh with what WebAssign did. Okay?
How are you submitting it? Through Canvas or email?
So to send me your PDF, is that what you're talking about?
Yes.
Yeah, through Canvas.
Is it going to be like an assignment that's posted?
No, you'll just send me an email. So after the exam, you'll send me an email of your PDF file. Does that make sense?
Could we get that address right now?
Oh, the email? well, you could just directly email me too if you want. It's in my syllabus, but that's fine. You can email me directly, or you could just on Canvas, just go to the email section and email me. But that's my email if you want to email me that way. How do you guys feel?
A little worried about the work stuff, but
You're a little worried about what?
a little worried about the work stuff, but other than that, pretty good.
Okay. Yeah, the work stuff will be okay. I'm definitely going to give you a cable problem. I'll probably give you like there's a homework problem that has a leaky bucket. I'd like that problem. It's a thoughtful problem, and then of course I'm going to give you one that's kind of straightforward with having inches instead of just feet, and then I'm probably going to give you a metric one too. So there'll probably be 4 work problems, and then the rest of it will be from chapter 12. Okay?
Got it.
All right, I'm going to
4
stop.
work problems. The rest will be chapter 12.
Yeah, so there'll be 4 from work, chapter 6.4, and the rest will be problems from chapter 12.
Okay.
All right, I'm going to stop recording.